Okay, and your slant asymptote formula is y minus k equals plus or minus b over a times x minus h. Kind of separate that a little bit. Kind of separate these. They seem to be running into each other a little bit. Alright, so let's say, for example, find the standard form of the equation of the hyperbola with foci -1, 2, and 5, 2, and vertices 0, 2, and 4, 2. Okay, so they're basically saying if we give you the 2 focus points and the 2 vertices, we want you to give us the equation. Okay, now the first thing I recommend doing is plotting your points. And there's a good reason for that. So if you have your, it doesn't have to be perfect. You don't have to put them in any specific order or anything like that. Let's say if you have -1, 2, and you can just put them there. So this is -1, 2, and you have 5, 2. We'll put that down here since it's all on the same line. Okay. And if we have your vertices of 0, 2, so let's say this is -1, 2, 0, 2 would be right there, and 4, 2 would be right here. And those are your vertices. Okay. We can see there that everything's lined up from left to right. That means if this is your vertex, it's safe to assume that these are both horizontal. So that's why if you can plot the points, you can figure out if they're horizontal or vertical. So we know just from this that this is a horizontal. Okay. Now once you do that, you can figure out now exactly which formula you want to use. So when it's horizontal, we know we're going to use x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, which means we have to find a squared, b squared, h, and k to plug in for our formula. Okay, so we know that, once again, we can go to our old reliable, the midpoint formula. So using the midpoint formula, okay, and remember that's just x1 plus x2 divided by 2, and y1 plus y2 divided by 2. We can actually solve for the center. Okay, because if you remember, your center is right there. And C, so this is our center. C is the distance from your center to your focus points. Okay, so we know that C is the distance from our center to our focus points. To solve for our center, and again, we're going to use the focus points. We're going to find the distance or the midpoint between these 2 points. So we can find the midpoint between those 2 points, we'll have our center. Or you can find the midpoint between the 2 vertices and find your center. So whichever one you want to use, you can use. So just using the focus points, that will be, and let me write out our x1, y1, and x2, y2. And see a good place I can put it where it won't be in the way. I'll put it right there. Okay, so if we have our 5, 2, and negative 1, 2, remember those are your focus points. Just make one our x1, y1, and our x2, y2. So if we plug it in, x1 plus x2 is 5 plus negative 1 divided by 2. And our y1 plus y2 is 2 plus 2 over 2. And again, if you want to use the vertices to find it, you could do that too. Okay, so that's 4 over 2, which is 2, and 4 over 2, which is 2. Okay, so this is your center. So we know we have our center. That means this is our H, and this is our K. Okay, so we know here, we decide to go up there just to point our 2, 2. Now the reason I say to graph it is because once you graph it, you can pretty much figure out your A and B from there. Well, at least your A. Because remember, forgot to put A equals the distance from vertices to center. Make that a little bit clearer. Distance from vertex to center. Okay. Now if we look right where we plotted those points, x equals 2 to x equals 4 has a distance of 2. Same thing with x equals 2 to x equals 0. So both of those a's will be the same. So you have a equals 2 there. Okay, and we already figured out that the distance from our focus points to center is C. So C equals distance from focus to center. Okay, so we know our focus is from x equals 5 to x equals 2, so we know that's a distance of 3. Uh-oh, it's spelled distance. It says A and C. So we know that C is equal to 3. So just say x equals 5 to x equals 2. And this is from x equals, that should be 4 to 2. Sorry about that. And this is x equals 5 to x equals 2. So we have our A, we have our C. Now the only thing we're missing, because we have our H, we have our K, we have our A, we're missing our B, which means we just have to solve, well, really just our B squared. So we know that B squared equals square root of C squared minus A squared. Uh-oh, I didn't square root it. I'm just going to leave it as B squared since we're going to need that anyway. So there's no point in square rooting it, so that's just C squared minus A squared. Okay, so if we plug in our C and we plug in our A, which we just figured out, we know that B squared equals C squared, which is 9, minus A squared, which is 4. So B squared equals 5. Okay, so now if we plug everything into our formula, that means our x minus h squared over a squared minus y minus k squared over b squared equals 1 will just become x minus h. Remember our h is 2. So x minus 2 squared over a squared, which is 4, minus y minus k, so our k is equal to 2. So y minus 2 squared over b squared, which is 5, equals 1. Okay, so that would be your formula there. All right, so any questions on that one? All right, I'll leave that up for a second. Alright, so let's say for our next example, we want to find the vertices and asymptotes for the hyperbola 4x squared minus y squared equals 16. Okay. Remember, hyperbolas are always equal to 1. So the first thing you want to do with this one is divide each term by 16. Okay, so once you do that, 4x squared minus y squared equals 16. We divide everything by 16. Okay, we have 4x squared, well, 4 and 16 cancels out, so 4 goes into 4 once, 4 goes into 16 4 times. So you have x squared over 4 minus y squared over 16 equals 1. Okay, so if we rewrite it, we can rewrite it as x minus 0 squared over 2 squared minus y minus 0 squared over 4 squared equals 1. Okay, so we know here that a is equal to 2 and b is equal to 4. A isn't always bigger than b for hyperbola. It is for an ellipse, but for hyperbola, b can be bigger than a. Okay, we also know that h is equal to 0 and k is equal to 0. Okay, so we have everything we need to figure out our vertices. Okay, so our vertices, because this is horizontal, is h plus or minus a, k. We'll kind of clean up that k a little bit so it looks more like a k. Okay, so we know that h is equal to 0. So you have 0 plus or minus a, 0. So if we stretch that out, it would just be vertices at 2, 0, and negative 2, 0. Or 0 plus 2, 0 minus 2. Okay. Now for your asymptotes, and again, this is horizontal. Oh, what happened to my, did I put that there? I don't think I put that yet. Here we go. I'll add that. So for our horizontal asymptotes, is y minus k equals plus or minus b over a, x minus h. Okay. One thing you want to remember is vertical asymptotes is y minus k equals plus or minus a over b, x minus h. So when you have a horizontal asymptote, it's going to be different than, a horizontal hyperbola is going to be different than a vertical hyperbola. Okay, so if we plug everything in, it's y minus 0 equals plus or minus 4 over 2 times x minus 0. So y minus 0 is y equals plus or minus 2 times x minus 0 is just 2x. Okay, so those are your asymptotes. Or your slant asymptotes, however way you want to say them. All right, any questions on that one? All right, so I'm going to go ahead and stop there.